Welcome to episode 2 of our series on public key infrastructure. In the last episode, we gave a high-level explanation of how a man-in-the-middle attack is implemented. We also explained fundamental computing concepts such as what is a local area network, how the internet works, and the meaning of confidentiality, integrity, and authenticity. In this episode, I'm going to demonstrate how to perform a man-in-the-middle attack. Specifically, I will demonstrate ARP poisoning and DNS poisoning. Some of you may know these techniques by the names of ARP spoofing and DNS spoofing. These are very popular techniques for performing a man-in-the-middle attack. I will show how anyone who knows how to turn on a computer can start performing these types of man-in-the-middle attack and start accessing confidential information. At this point in time, I'm going to skip providing a definition of ARP poisoning and DNS poisoning. These definitions won't make sense to some of you at this point in time. So it is better that I demonstrate a few things first before I explain ARP poisoning and DNS poisoning. Before I go further, I want to say that please use all information presented in this video ethically. We are learning specific mechanisms of man-in-the-middle attacks just so we can learn methods to defend against them in upcoming episodes. Please don't use information presented in this video for unethical, malicious, or criminal activities. Alright, so let's continue. I currently have the following setup. On the left is one of my local area networks. I have a typical D-Link router that most households, restaurants, or coffee shops would have. The D-Link router is connected to a modem that connects to the internet. There are two computers on this local network. I have a laptop that is running the Ubuntu operating system that will act as the man-in-the-middde attacker. When this laptop connected to the Wi-Fi network, the router automatically assigned the laptop the IP address of 192.168.10.104. I also have a Windows 11 computer that will act as the victim's computer. When this computer connected to the Wi-Fi network, the router automatically assigned this computer an IP address of 192.168.10.101. I also have a website on a virtual server somewhere on the internet. The website has the URL http://demo.evermite.net. The web page just shows a login screen. If you press the submit button, the page just reloads and nothing else happens. So let's take a closer look at the victim's computer. This here is the victim's computer. I'm going to open up the DOS command line just to confirm that the IP address is 192.168.10.101. So when I type the ipconfig command, I can see that this is indeed the 192.168.10.101 that we are expecting. Also notice that we can confirm that the router address or the gateway address is 192.168.10.1. Let's look at the attacker's computer. Now, I know I said earlier that the attacker's computer is going to use Ubuntu, but this laptop actually uses Windows as the host operating system. That's because this laptop is used in my office for other development and QA purposes, so I can't just wipe out the Windows operating system. So instead, I cheated and I used VirtualBox to install Ubuntu as a guest operating system. This should work the same as if I had a laptop that only uses Ubuntu as the host operating system. I have 3 SSH sessions opened up to the Ubuntu machine. We will use these 3 windows to give instructions to our Ubuntu machine. Let's confirm that the IP of this attacking machine is indeed 192.168.10.104. I will type the command IPA. So you can see that it's confirmed the IP of this attacking machine is 192.168.10.104. So let's go back to the victim's machine for a moment. I'm going to type the command ARP -A. To understand what you're seeing here, let me provide a few definitions. The first term I want to define is Media Access Control Address, or the MAC address. Every device that has Wi-Fi or networking abilities needs something called a network interface card. Sometimes it's called the network interface controller, or the Wi-Fi card, or the Ethernet card. When a manufacturer like Realtek or D-Link makes a network interface card, it assigns it a unique ID that we call the Media Access Control address. You can basically think of this MAC address as a serial number for the physical device, and this number will never change. The next term I want to define is Address Resolution Protocol, or ARP. ARP associates an IP address with a MAC address. As a reminder, IP addresses are issued by routers and IP addresses can be reused. But MAC addresses are fixed and they never change. So ARP is a protocol to keep track of which MAC address an IP address is pointed at. If I were to use an analogy, think of IP address as the address of a house, and think of MAC address as the names of the people who are living in that house. ARP is like the postal service that keeps track of who's currently living at which address. Coming back to the victim's computer, when I type ARP-A, I ask the computer to tell me all the IP addresses that it is aware of and which MAC address is assigned to each of them. In other words, for each IP address, which physical network card or physical Ethernet card is associated with each IP address. The victim's computer can see that the gateway address of 192.168.10.1 has the MAC address of C0A0BB C7E866. I verified before through other system details that this MAC address is indeed the MAC address of the network interface card inside my D-Link router. From the victim's computer, we can also see that the address 192.168.10.104 has a network card with this MAC address. And I also know that this MAC address is indeed the MAC address of the network interface controller inside my laptop. The important point here is that each IP address is pointing to a different MAC address, because later, an indication that a man-in-the-middle attack has occurred is when 192.168.10.1 shows the same MAC address as the 192.168.10.104. I will explain more about this later when I run the man-in-the-middle attack. Now let's say I open a web browser and visit demo.evermite.net. You can see that a web page loads up. When loading up the web page, the network traffic travels a path similar to the one denoted in the red lines of this diagram. So this is all good, because everything we've seen so far indicates no fraudulent activities. Now we're ready to begin a man-in-the-middle attack. Let's start with a technique called ARP poisoning. ARP poisoning means an attacker will disrupt the ARP records of other machines on the local network. Specifically, the attacking machine will tell the router that the IP address of 192.168.10.101 should map to the MAC address of the attacker's machine. Additionally, the attacking machine will tell the victim's machine that the gateway IP address of 192.168.10.1 should also map to the MAC address of the attacker's machine. So basically, the attacker fooled the victim into thinking that the attacker's machine is the gateway, and the attacker fooled the router into thinking that the attacker's machine is the victim. The attacker can easily do this with the ARP spoof command that comes with the dsniff package. So let's go over to the attacker's machine. To install dsniff on the attacking machine, let's update our Linux package repository with the latest definitions. And now I can install dsniff with the command apt-get install-y dsniff. That seemed pretty quick, and I just realized the installation was very fast because I had dsniff installed already. If you're installing dsniff for the first time, it might take a few seconds longer. To run the ARP spoof command, I need to know the network interface name for the Wi-Fi network that I am connected to. So I can see that from the IPA command that the interface name is ENP0S3. So now let's run the ARP spoof command. I will type ARP spoof -I ENP0S3 and -T to target 192.168.10.101 and tell the victim that I am the router at 192.168.10.1. And I will also add the -r command, which basically repeats this exact same command, but swaps the role around. It will target the 192.168.10.1 and tell the router that I am the victim's computer at 192.168.10.101. Oops, just a typing mistake, so let me fix that. Okay, so now you can see that this attacker's machine is transmitting new ARP records to both the victim's machine and the router. You can see that new ARP records need to be sent every few seconds to get around any issues related to caching. ARP poisoning is not an exact science, so this could require a few repeated attempts. Let's go back to the victim's machine. You can see that about 5 minutes ago, when we ran the ARP-A command for the first time, the gateway IP address had this MAC address that ended with 66, and this reflects the MAC address of the network card in the router. If I type ARP-A again, notice how the gateway IP address has a new MAC address, and this MAC address is the same as the one at 192.168.10.104. This means that anytime this victim's computer sends information to 192.168.10.1, it will actually be received by the attacker's computer, since the MAC address of F8.16.54.9B70DA belongs to the network card in the attacker's computer. So at this point, the attacker has successfully implemented man-in-the-middle. All traffic between the victim's computer and the router, and the rest of the internet, will enter the attacker's machine. Let's go back to the victim's computer. Now, let me reload demo.evermite.net. I waited a few seconds, but the page failed to load. I think I forgot one more step. My guess is that right now, the attacker's machine is receiving traffic from the victim's machine, but it's not being forwarded to the router. And the attacker is receiving traffic from the router, but it's not being forwarded to the victim's machine. I need to enable IP forwarding on the attacker's machine to let the traffic actually flow through to either side. Let's return to the attacker's machine. If I open the file proc sys net IPv4 IP_forward, I can see the number 0. This means that IP forwarding is not turned on. Let's change this 0 to 1 so that the man-in-the-middle attacker will forward all incoming traffic. Now let's go back to the victim's machine. I'm going to reload this URL, and now we can see that the web page loads. So that's great because it means that the man-in-the-middle attacker is letting traffic flow through to either end. Now let's demonstrate just how dangerous this situation is. Let's start by having the attacker's machine read all the traffic on port 80 with the TCP dump command. Coming back to the attacker's machine, all you have to do is type TCP dump -I, the name of the interface, -A, TCP port 80, and press enter. This will stream all the web traffic between the victim's machine and the router to the screen of the attacker's computer. Now let me show the screens of both the victim and the attacker side by side. On the left, I am going to reload the web page of the victim's computer. On the right, notice that all the web traffic between the victim and the router is being streamed to the monitor of the attacker's computer. This can be hard to read, so I'm going to change things a little bit. Instead of printing all the traffic to the screen, I'm going to record all the traffic to a text file. That way, I can review the text file at a later time. Let me just zoom in on the attacker's computer. I'm going to run the TCP dump command again, but change the -A flag to -W and give the file name that I want to save the traffic to. After I press enter, the traffic dump should be active now. Let's go back to just the victim's computer. I'm going to fill out this login form with the username johndemo@demo.com and the password ABCD1234. Then I'll press login. Alright, the page just reloaded. So now let's go back to the attacker's machine. I'm going to press Ctrl+C to stop the TCP dump and open up the traffic.txt file. You will notice that all the web traffic between the victim and the router is now in this file. If I search for the text johndemo@demo.com, you can see that both the username and the password ABCD1234 was captured in human readable format. And just like that, the attacker now has access to confidential information between the victim's computer and the router. We just showed how simple it is to use ARP poisoning to perform a man-in-the-middle attack and compromise confidentiality. Some of you are probably already thinking ahead and saying to yourself, but when I prefix URLs with HTTPS, does that not mean that I am using TLS certificates to encrypt web traffic so that even if a man-in-the-middle attacker gets a hold of the traffic, nothing will be human readable to the attacker, right? The short answer is yes, but the long answer is that's still not enough. Encryption and TLS certificates are topics of future episodes, but for those of you who think you know what they are, let me demonstrate how a man-in-the-middle attacker can circumvent the defenses offered by encryption and TLS certificates. Before I begin, let's go to the victim's computer. Let me go to a website called bestbuy.com. Best Buy is a very popular department store in North America. Notice that the website does have HTTPS and is using a valid TLS certificate. This just means that any traffic between the victim's computer and the router and the Best Buy servers is encrypted. And also, encryption means that the traffic is scrambled in a way that the only devices that can unscramble the data is the victim's computer and the Best Buy server. I can confirm this fact for you by investigating the traffic between the victim's computer and the Best Buy server. Let me go back to the attacker's computer. I'm going to restart the TCP dump, but this time I will record the traffic to a new file called trafficbestbuy.txt, and I will monitor traffic on port 443 as well, since that's where HTTPS traffic is normally transmitted. Now, let's go back to the victim's computer. Let's head over to the login page. I don't have an actual Best Buy account, but that does not matter. If I try to log in with johndemo@demo.com and the password ABCD1234, Best Buy will tell me that the account does not exist. So let me press sign in. This computer just sent credentials over the local area network. Now let's go back to the attacker's machine. Let me stop the TCP dump and open up the trafficbestbuy.txt file. Notice that nothing in this file is human readable because it has all been encrypted. Even when I try to search for the term johndemo@demo.com, nothing shows up. Some people may assume that this is the end-all and be-all of web security, but this would be a dangerous assumption. Let me present to you a new technique to perform a man-in-the-middle attack which circumvents the benefits of encryption and TLS certificates. The technique is called DNS poisoning. Here's the definition from Wikipedia. DNS poisoning, also referred to as DNS cache poisoning or DNS spoofing, is a form of computer security hacking in which corrupt domain name system data is introduced into the DNS resolver's cache, causing the name server to return incorrect result record. This results in traffic being diverted to any computer that the attacker chooses. To understand what this means, recall in the last episode that I mentioned that domain name system, or DNS, is a computer's way to translate a domain name to an IP address. And every device taking part in the delivery of web traffic could have its own set of cached DNS records. If any device delivering web traffic uses incorrect DNS records, the traffic will not arrive at the intended destination. When there is a man in the middle of two devices, the man in the middle can introduce incorrect DNS records and route traffic from the victim or the router to anywhere else. Let me explain a practical usage of DNS poisoning. In our setup, the man-in-the-middle attacker can pretend to be www.bestbuy.com. First, the attacker installs a web server and creates a login page on his own computer. A real hacker would make the login page look exactly like the Best Buy's login page to trick their victims. But for the purposes of this demonstration, I will just reuse the login page from demo.evermite.net. This way, it will be very clear that DNS poisoning has occurred when typing in www.bestbuy.com shows this login page instead of this login page. Next, the attacker uses the DNS spoof command, which came with dsniff package, to route all web traffic from www.bestbuy.com to the login page on the attacker's machine. By pretending to be a website that it is not, the attacker is breaching authenticity, which is one of the security criteria that we defined in the first episode. The attacker will also have the opportunity to alter any data, which means they can also breach integrity, which is yet another security criteria that we defined in the first episode. Now, let's do a practical demonstration of this. Let's return to the attacker's computer and let's exit this file. Now, let's install a web server on this computer so that we can host a website with a login page. To install a web server, I simply type apt-get install-y apache 2. This might take a few seconds. Alright, it looks like Apache web server has been installed. And from my experience, I know that there is a directory at var www.html that will be used for our web pages. And I can see a default index.html file. When I open up a web browser to the IP address of this attacker's machine, I see that the default index.html file does load up the way we expect. So that's great. Now all we have to do is replace this page with the login page that we're going to download from demo.evermite.net. And it looks like the file's here. I know there's a style sheet, so let me just find the file name for that. Okay, so it's style.css. So I will wget that style.css file as well. And now if I go back to my web browser and press refresh, we see a fake login page. So I think that's great because now we have a login page that we can use to deceive our victim. So all that's left to do is to replace the Best Buy login page with our fake login page. And we do this with DNS poisoning. Let's go back to our main directory and I'm going to create a new text file and I will just call it MITM. In this file, I'll type in the IP address of this attacker's machine, which is the 192.168.10.104, and then I will type www.bestbuy.com, and I'll also add bestbuy.com. So what this will do is that later when we run the DNS spoof command, the DNS spoof command will read this file to perform the DNS poisoning. This file basically says that anytime someone tries to visit the domain www.bestbuy.com or bestbuy.com, then translate the domain to the IP address of 192.168.10.104. The result will be that web pages from this attacker's machine will be served instead of the web pages from the actual Best Buy website. So I'm going to exit this file. I'm going to start DNS poisoning with the command DNS spoof-I, the network interface name, -f, and the MITM file. Alright, DNS poisoning might be in progress. Sometimes I might need to restart this command a few times. To know whether it really is in progress or not, we will need to go to the victim's machine and observe what happens when a web browser visits www.bestbuy.com. I am back at the victim's machine now. I am going to open up www.bestbuy.com. And it looks like we are seeing the spoofed fake login page. If the DNS poisoning did not work, then this page may time out, or I might actually see the real Best Buy login page. DNS poisoning, like ARP poisoning, is not an exact science, so you may need to do this a few times before things work. But since things are working this time, you can see how dangerous this is. If the victim uses this login form, this form could be hooked up directly to the attacker's backend database. Also, notice that this spoofed site isn't even using HTTPS. Whether it is using HTTPS or not does not even matter because the HTML code in this login form could just redirect you to anywhere the attacker chooses. So now you can see one of the ways you can use DNS poisoning or DNS spoofing to circumvent the protective benefits of encryption and TLS certificates. We used ARP poisoning to access confidential information, we used DNS poisoning to breach content integrity, and we used DNS poisoning to assume the identity of another machine, which violates authenticity. Hopefully, by now, you can see just how easy it is to perform a man-in-the-middle attack. We just demonstrated with ARP poisoning and DNS poisoning, but there are so many other ways to perform a man-in-the-middle attack. If I have time, I can demonstrate a few more attacks techniques in the future. In the meantime, you should be ready to learn how to defend against these attacks. In the next episode, we will learn about encryption. I still need a few days to maybe a few weeks to prepare the next episode. So if you want to be notified of when it's ready, then subscribe to this channel and hit the notification bell. Thank you for watching and see you soon.